All right. Okay, doing science, we're continuing the discussion of telescopes. We're going to start on page 120. There will be some video clips for you to watch after this, and then homework questions also. Okay. All right, here we go. Okay, we're going to talk about the different types of telescopes. It starts off, it talks about on a clear night, your eye can see at most a few thousand stars, but with a telescope you can actually see millions. Why? Because the light from the stars spreads out as it moves through space, and your eyes are actually too small to gather that much light. Okay? And of course, telescopes are instruments that collect and focus light and other forms of electromagnetic radiation. Okay? Telescopes make distant objects appear larger and or closer and brighter, if you would. A telescope that uses lenses or mirrors to collect and focus visible light is called an optical telescope. Okay, that's the ones that you actually look through. That's an optical. Okay, we do have different types, obviously. In fact, there's different types of optical. Okay, the one I have back there that hopefully we can put up and look through a little bit is a refracting telescope. That means it uses lenses. Okay, it uses lenses. It's not actually, they're not as good as when they came out with the reflecting telescope. It was deemed better than a refracting. Okay, a refracting uses a convex lens to gather and focus light. Okay? How many of you know what a convex lens is? As opposed to a concave. Okay? Nobody? All right, let's take a look at it. I drew it out for the last class. This is not something if you don't think about a lot. Okay? That's the pictures. That is a convex. That's a concave. Okay? Okay. All right. Now, yeah, it's kind of, they can be different. I mean, it can actually be a full lens like this. It can come all the way down like this. As long as a convex, the middle is thicker than the ends. Okay? A concave caves in. Okay? It caves in. Think about, a good way to remember it is, think about a cave entrance. Okay? So when you see this on a test sometime, and you will, because we will actually study lenses and things when we get into light and sound. We will actually talk about lenses and things like that again. So you're going to see this. All this kind of starts to tie in together as we go through the year. Okay? So you're going to see these things again. Okay? But that just kind of gives you an idea of what they're talking about right there. Okay? But a refracting telescope uses two convex lenses, one at each end of a long tube, okay? And the light enters the telescope through the large objective lens at the top, and then it comes in and it actually crisscrosses it as it comes through the other lenses. How many of you know that when you look at something with your eye works a whole lot like this? Okay. When you look at something with your eye, your eye picks it up upside down.
Really?
Yep.
And your brain turns it
Your brain turns it around so you're seeing it correctly.
So if my brain didn't turn around, you'd be upside down, right?
I'm surprised I'm not upside down for you right now.
Leo! Or the mask on Leo!
Yes. I know. That was mean, wasn't it, Leo?
Why are your feet talking?
Why am I being mean? But yeah, your eye actually, and we'll talk about that more also, but your eye actually will pick it up upside down and your brain flips it over. So
it's just my destiny to get burned by like everything.
Pretty cool. Okay. All right. A reflecting telescope. Think about reflecting, okay, because you're going to have to know the difference in refracting and reflecting, okay? A good way to remember that is reflecting. What does a mirror do? Reflects. Guess what a reflecting telescope uses? Mirrors.
Or does it?
Yeah. No, it actually does.
It reflects what? It's a
It
cannon.
reflects light, but it uses mirrors.
Small
to do that.
cannon.
Okay? In 1668, Isaac Newton built the first reflecting telescope. Okay? A reflecting telescope uses a curved mirror to collect and focus light. Like the objective lens in a refracting telescope, the curved mirror in a reflecting telescope focuses a large amount of light into small areas. Okay? The larger the mirror, the more light the telescope can collect, and the larger optical telescopes today are all reflecting telescopes, all the ones in the observatories and all that. Even the Hubble spacecraft is a reflecting. It has a giant mirror, about 5 foot across, I think it is, that gathers the light. That's the lens on there. Okay? And radio, remember the clip that we watched where all the planets were making sound?
Yeah.
That was picked up using a radio telescope.
Oh.
Okay?
Yeah.
Now, a radio telescope, obviously, you don't look through it, okay? But it's a huge, it looks like a satellite dish, but it actually is a reflector in there, okay? And it has the little antennas and all that stuff, and it actually picks up. And the bigger it is, the more it can pick up. It's kind of like, you know, the bigger the lens on a telescope, the more light allows in, the more you can see. Radio telescopes the same way. The bigger they are, the more sound that they are out to pick up. Yes?
If we had a lens as big as this room, do you think we could see to like? So
Oh, we've got lenses. I mean, there's telescopes out there that
Right.
are huge. I don't know if they're as big as this room, but they're pretty
If
big.
there was a lens as big as this room, and then the other side had one like this big,
Okay,
then
you know the answer to that.
yeah.
Yeah. The
No,
bigger the
be
lens,
able
the
to
more
see
light
through
it
it.
allows in, the more light that allows in, the better you can see. Okay? So yes, a bigger lens is going to be better than a little lens. Yes, Frank?
So my grandpa said that, so like his neighbor down in Florida, he said that, he had a telescope out and he could see the craters on the moon.
Yeah, you can do that. You can do that even with that little one I got. He's talking about with a telescope, you can see craters on the moon and things. You can do that at night, even with that little one back there, and that's a cheap model I bought my son when he was young. Okay? Other telescopes, okay, we have some telescopes detect infrared radiation, which has a much longer wavelength than visible light, but shorter wavelengths than radio waves, okay? There's also telescopes that detect the shortest wavelengths, like ultraviolet radiation, X-ray, and gamma rays, okay? That's what turns you into the Hulk.
Like the Hulk?
Yeah,
Wait, seriously?
yeah, that would turn you into the Hulk if you're exposed to gamma.
Turn into something.
We know that for a fact because we saw it on the movies.
Yeah.
So it must be true.
Same with Karate Kid. Karate Kid, it can be opposite. It just
Okay.
connected.
All right, now observatories. And we have some around here. Different college has an observatory. G-Tech has one down on their Jamestown campus that you can actually go to. I did check last night. They are Friday nights. Apparently you can still go down and view. I would call before I drove all the way to Jamestown to do that a bit, but that's pretty cool. But they allow people to come in and look through their big telescope and all that and
How big is
see stuff. It's pretty good size. I mean, they've got a pretty nice little astronomy department going on down there. They've got it set up so it transferred to a 4-year degree. So if you wanted to get your degree in astronomy and then go on to be like an astrophysicist or something like that, you know, you could start there and work your way through. Yes. Yeah. All right. In general, an observatory is is a building that contains one or more telescopes. Okay, it contains one or more telescopes. However, some observatories are located in space. Many of the large ones are located on mountaintops. Okay, we have them in space also, but we also have observatories on mountaintop. Why do you think it might be on a mountaintop?
Because it's higher up.
What do you think?
Well, because it's like higher up and there's not as many like city lights and stuff.
Okay, higher up, not as many city lights. What do you think?
It's above the cloud level.
It's above, sometimes above the cloud, and the atmosphere. Believe it or not, the Earth's atmosphere is thinning out. The higher up you get, So it also doesn't interfere.
Like,
So there's a number of reasons, and all of you were correct. Everything you said was exactly right. Yeah.
this might sound dumb, but is there one on the top of Everest yet?
No,
Yeah.
no.
That's what I thought.
That would be silly.
It says no.
Okay. Earth's atmosphere makes an object in space look blurry. So the sky on some mountaintops is clearer than at sea level. And it's not brightened much by the city lights, okay? Unlike optical telescopes, radio telescopes do not need to be located on mountaintops, okay? They can be located anywhere, okay? One of the best observatories is actually in Hawaii on one of their dormant volcanoes, which means the volcano is not erupting and they don't expect it to erupt anymore, which is why they built the
And
observatory
then
there.
right now, as soon
Yeah.
as you say that, you jinxed it.
You jinxed it.
It's possible.
Wait, it's like the entire rock shelf.
It's about 4,200 meters above sea level. And that is about 40% of the Earth's atmosphere. Okay, so it's on up there a ways. Yes.
Okay, so I bet that during wars, armies have used like radio telescopes to pick up enemy communications.
We do use satellites and things to get their locations and all that.
Like right now in Afghanistan,
Yes.
we use those, but like
Just drop them
in
in.
Cold War, we use satellites instead of telescopes.
Yeah, and we still do. We still get images. I mean, we're talking about satellites now, but they are in space, so it ties in. We do have satellites that, I mean, we can get pictures of enemy movement and things like that.
But Osama didn't.
All the time. So.
They knew the exact room he was in and the exact.
They did. Okay. Advanced telescopes. Today, many large optical telescopes are equipped with systems that significantly improve quality of their images. Okay. Optical telescopes on Earth equipped with such systems are able to produce images of small regions of the sky that rivals those of optical telescopes based in space. Okay. Some new telescopes are equipped with computer systems that correct images for programs such as telescope movement and changes in air temperature or the mirror shapes. Other advanced telescopes uses lasers to monitor conditions in the atmosphere. The shape of the telescope's mirror is automatically adjusted thousands of times each second in response to changes in the atmosphere. Is that not cool?
Yeah.
That they can do that? That's amazing. Yes, Leo. Okay. And you see down here at the bottom on page 122, it kind of goes over some different ones when they were built, how some things happened. Okay. If you've ever seen an observatory, the ones that are on the mountain, these things are really huge. They're like dome shaped. Of course, they open up. It's not like the telescope is setting up on top of it. It's actually inside this thing, and it's massive. You're actually standing on the floor looking through a little eyepiece, and this thing is massive going up. But the dome will open up. Some of them actually will rotate. And the telescope and everything rotates with it, of course, and that way they're
Isn't
not
there
just.
a hatch at the top where it opens up when it extends?
Well, it opens different ways. Some of them's got doors that opens this way, some of them peels back, so they're designed different ways.
Like if something was gonna happen, like if something might damage the telescope, can the telescope retract? And
Yeah,
then close back?
it goes back down inside. Yeah, it goes inside of it. Okay, but you see, we're going to talk about the space, the Hubble Space Telescope. It was launched in 1990, and it's still going. They were planning on launching one to replace it a few years ago. We had to cut back to NASA. It didn't get launched. It is called the James Webb Space Telescope. It is now scheduled to launch in 2021. Okay, So hopefully that's gonna go up. It will replace the Hubble.
Is it gonna go faster?
It's a little bit bigger, but it's the same, basically same design. It's just that the Hubble is getting old.
Yeah.
I mean, for a telescope, it's 30 years old.
Is it gonna be able to send out pictures quicker and stuff?
Probably, I'm sure it's got better technology. I mean, technology has changed quite a bit in
Maybe
30
you
years.
can send it to the International Space
Yeah,
Station,
so-
and they can send it there.
Yes, Leo?
So what is that spacecraft that it doesn't have any people on it, but it's like a million light years out. What is it called again?
Oh, you're talking about the Probe.
Yes,
Yeah.
the space probe. Isn't it like never gonna come back?
No, it's not coming back.
Wasn't it?
It's going away from Earth at something like 40,000 miles an hour.
Wait,
Is
it's
it
supposed,
still
it's
sending
supposed to
pictures?
find life and introduce
it's
them
still
to
fine.
like customs and shit.
All right,
Has all
we're gonna talk about all that
languages
stuff a little bit later on. Okay, not
I
today.
wonder if we
and
can.
stuff.
We're gonna talk about all that stuff a little bit later on. Not today.
Don't judge them.
Not today.
Yeah, it's not
Judge
true.
one right
Y'all hear me say not today, right? Y'all can hear it. Okay. Want to make sure the sound was up for y'all because obviously it's not up here. Okay.
We just need
Yes,
a mute-
Braxton.
We just need a mute button.
So you know when there's
No.
like apps that you can see like all the stars on the planets? I mean like it tells you where they are on space.
Yeah, you got charts and things that tells you where the various stars and things
Yeah.
are.
So
Absolutely.
it told us where like the Hubble Space Telescope was like it's like on the other side of the Earth.
That's cool. That's really cool. Okay. Telescopes in space, you got X-rays, gamma rays, and most ultraviolet radiation are blocked by Earth's atmosphere. Okay. To detect these wavelengths, they have placed telescopes in space. Some of the space telescopes are designed to detect visible light or infrared radiation, since Earth's atmosphere interferes with the transmission of these forms of radiation. The Hubble telescope is a reflecting telescope with a mirror of 2.4 meters in diameter. When they first launched that thing, and it started sending pictures back and things, it was blurred. Okay? So they actually sent a crew up that docked with this thing and got out in spacewalk and polished this giant mirror in space after it had been launched. Is that not cool that they can do that? Yeah, is that, I mean, that's just, what'd you do today, honey? Oh, I polished the mirror. 340 miles out in space. It's pretty cool. The hottest object in space gives off X-rays, okay? And they do have observatories that picks up all this stuff. I mean, they actually monitor it and investigate it and study it and all that good stuff, okay? So there it is. I mean, we're constantly learning more. If you like amateur astronomy, you know, if you get into this stuff, you can't go out and, I mean, it's like every other day something, they have discovered something or they have corrected something or, I mean, it's a constant changing field. And because we're learning more and more, things that we thought we knew have been proven wrong. I mean, it's pretty cool. It's great. It's a lot of fun if you're into this type of stuff. And hopefully you are also. And we will talk to y'all later.